Today we discuss second colligative property. The name of the colligative property is boiling point elevation. आज आपण दुसरी colligative property म्हणजे boiling point elevation ही बघणार आहे. First, boiling point means the temperature at which vapor pressure of liquid becomes equal to atmospheric pressure at a given constant pressure is called as the boiling point. Then elevation of boiling point means it is difference between the boiling point of the solution and that of the pure solvent. It can be denoted by delta TB. Delta means difference, TB means boiling point. Difference between the boiling point of the solution and that of the pure solvent. Then graphical representation of elevation of boiling point. We can plotting the graph of the vapor pressure versus temperature. आपण vapor pressure and temperature graph काढला तर याच्यामध्ये there must be the two curve. One is what is the AB and second is CD. AB represent the vapor pressure of the pure solvent and CD represent the vapor pressure of a solution. From the graph, it is clear that CD can be lies below the AB means vapor pressure of solution is always less than that of the pure solvent at any temperature. Then according to the definition of the boiling point, at point A, the vapor pressure of pure solvent becomes equal to atmospheric pressure. Therefore, the point A is called as the boiling point and temperature is called as the boiling temperature. Temperature TB0 is called as the boiling point of the pure solvent. At the same temperature, vapor pressure of solution is lower than that of the atmospheric pressure than the value of the delta P. To increase the vapor pressure by the value delta P, we must be heat the solution at higher temperature. Then at point C is the boiling point of the solution because at C point vapor pressure of solution becomes equal to atmospheric pressure and temperature is called as the TB is called as the boiling point of solution. The different delta TB is directly proportional to delta P. Means here delta TB means elevation of boiling point is equal to difference between the boiling point of solution and that of the boiling point of the pure solvent. And delta TB can be directly proportional to delta P means lowering of vapor pressure. It is a graphical representation. Next point is boiling point elevation and concentration of solution. Practically or experimentally it is verified elevation of boiling point delta TB can be directly proportional to the molality of the solution. Small m is the symbol of the molality. Direct proportional is equal to by using the constant delta TB is equal to Kb into m. Kb is equal to delta TB divided by m. If m is equal to 1, Kb is equal to delta TB. Kb is called as the molar elevation constant, ebullioscopic constant or boiling point elevation constant. Ebullioscopic constant or molar elevation constant is elevation produced by the 1 molar solution is called as the Kb. And unit of Kb is equal to delta Tb, the temperature, it can be measured in the Kelvin. M means molarity, it can be measured in the mole per kilogram. Then unit is equal to Kelvin kilogram mole inverse is the unit of the molar elevation constant or ebullioscopic constant. Next point is determination of the molar mass of solute by using the boiling point elevation. We know that the delta Tb is equal to Kb into m. M means the molarity of the solution Molarity can be denoted formula. Molarity M is equal to W2 into 1000 divided by M2 into W1. Putting this value in the above equation, delta TB is equal to KB into W2 into 1000 divided by M2 into W1. Rearrange the equation. M2 is equal to KB into W2 into 1000 divided by delta TB into W1. Knowing the values of the KB, W2, W1 and delta TB, you can easily calculate the molar mass of solute M2 can be easily calculated. Next lecture you can discuss about the differential in freezing point.